All right. So did you guys spin these the other day?
Yeah.
Okay. Which one was more difficult to get to rotate? The blue one. If you haven't felt these, you need to feel them because it's such a stark difference. Okay.
Can I feel them again?
So the difference here is that the red one,
Yeah.
and the blue one, they have the same mass.
No teaching.
Okay? They have the same mass and the same length. Which one's easier to spin? Why is the red one so much easier to spin?
It has less rotational inertia or something.
Yeah.
Why is that true though?
Because of the mass.
Because the mass is distributed towards the center instead of on the outside of the
So this has all, like, there's like nothing at the ends, and then this is like, oh, okay.
So here's what the weight distribution looks like. Okay? So the red one, all the mass is in the middle. The blue one, the masses are on the outsides. So they have a different rotational inertia. So our framework for this, the rotational inertia, okay, it depends on two things. Okay? The rotational inertia is the sum, that is a Greek letter sigma. Can you see the sigma?
Yes.
Of all the mr squares.
Of all the
What's that?
what did you say?
Yeah, it's the sum, that's what the little sigma means, of all the mr squareds. And so what we do here is we can say like, well, what does this mean for, what does this mean for the top one? They have the same mass, but what's different about this one? Yeah, because the masses are concentrated at the middle, the radius is smaller, so this one has a much smaller rotational inertia. This one, the stuff is on the outside, so it has a much larger rotational inertia. Okay? Rotational inertia is a measurement
I think.
One on the other.
Would the I have like a little R at the bottom since inertia is also I? Or
No, inertia is not a thing. Our measurement of linear inertia we call mass.
and then inertia is only so there's either linear or
So linear inertia, we just call that mass. Rotational inertia we call rotational inertia, or moment of inertia. Yes?
So in this case, the radius is like the distance of the mass? Like,
Yes, that's what it always is.
Yeah.
So in terms of R in this case, it's where the mass is distributed, the radius of the distribution of the mass. We're going to see a couple examples.
Okay.
Okay? So measurement of...
would the radius be from the center of the object?
Okay. Makes sense. So the only value that's changing between the two is R, because mass, you said, is the same. So
And
that's what changes inertia.
Mm-hmm.
the R is measured from the middle of the object?
Sometimes, it's in this case it is, it's measured from the point of rotation. So there's an axis of rotation, it's measured from that.
So it's not from the center of mass, it's from where it's spinning from.
Yes.
Yes, and we're going to see a couple examples of both. So linear momentum, or sorry, linear inertia, which we call mass, is a measurement of an object's resistance to change in linear motion. Right? It's harder to move a bowling ball than it is to move a basketball, because it has more mass. Right?
Yes.
The blue one is harder to move. It's harder to get it to rotate, right? It's harder to get it to rotate because of the fact that it has more rotational inertia. Okay, cool? I'm going to do a visual demonstration of this. Are you ready? So let's go back to our demonstration from yesterday. Sorry, just take my knot out. Worst demonstration ever.
No, it's all right. I'm enjoying.
What's that?
Let's look.
Sada, it was really funny. I made the same, after you turned in your test yesterday, I made the same error you did.
Oh.
And then I was like, what the heck did I do wrong here? And then I couldn't figure it out because I knew all Claire's work was right, but she wasn't getting the same answer as you and I did. I'm like, this is a problem.
If me and Sod got this, it can't be wrong. That's crazy, actually.
Okay, sorry about that. So we're gonna do the same thing. And I want you to get a visual sense, okay?
Oh, I see, yeah. Sweet.
Okay, you guys ready? I want you to get a visual sense of the rotation of the pulley, and you can either get it from the rotation of the pulley or the rotation of the mass, because they're gonna have an analogous rotation. Did you get a sense of it?
Yeah.
Okay? We could time it if we needed to, but this is not, we don't need to be specific about it. Did you see it go? Okay, got a good sense of it? Now, what I'm gonna do is I'm gonna add these bars to it.
So,
What is that?
What is it?
Nothing, it's just your phone out.
Claire, do you need to go off and out of sight?
Yes. Such a hypocrite.
Yeah, Jack.
I've never been on my phone in my life.
Oh, really? What up to the, no?
oh, what's it? Oh, that is.
Are you guys ready?
Yeah.
Now, do you think when I let this go, it's gonna have more rotation? I'm sorry, more acceleration or less acceleration?
Less acceleration.
Less?
I think it's not the same.
More?
Less.
Same?
Please, take a more answer.
I'm gonna say that.
Undefined acceleration.
Yeah!
What do you notice?
It didn't accelerate as fast.
Much less acceleration.
Oh, but it
Why?
went farther back up the.
It did. I'll tell you why in a second. Why does it have less acceleration? I added two things. Did I add more mass to it?
Yeah.
Yes. Did I also distribute that mass farther from the center?
Yeah.
So I maximally increased the moment of inertia, which means it's harder to get it to go, but once it's going, it's also harder to bring to a stop. Which means that as it passes the bottom, it has a lot of rotational inertia, so it keeps spinning and it brings the thing back up. Isn't that cool? Right?
It's so satisfying.
Oh, it's super satisfying. I'm gonna put the masses on.
You probably do them.
You gotta increase it even more.
We're gonna see. All right, Jack's statement is a good one. Okay.
Question, it's gonna speed it up.
Yes.
Trick question.
Jack says, is this going to further increase? Is it gonna further increase?
Yeah.
The inertia,
Okay. The rotational inertia? So what should be true about the acceleration now?
Slower.
Even less?
Yeah.
But it's gonna
Now
come almost
gonna
all the way
go
back
up.
up.
Crazy.
Oh, it grabbed down to the thing. That was funny.
You gotta redo that.
All right, so now I've added even more mass, right? And then what's the last part of the demonstration?
Put it all the way out.
Oh.
Oh my god.
Bigger radius.
Make sure it doesn't get tangled. I really wanna see it go all the way out.
So why is it R squared and not just MR?
It's not
Oh.
Because, you have calculus right now?
Yeah.
So it's actually, when you measure this, it's actually, okay, look at it.
Oh.
No,
Oh,
just
it's
let
about
that
to,
go.
it's about to go crazy.
It's gonna go all the way back up though, right?
Hopefully.
It might not have a, I don't know.
It's not fast,
Oh,
there's no
wait.
way.
It
Oh.
didn't get enough speed.
It also
I
got.
think you should spin it.
That
Spin it
came
so it
way
goes
further
down.
up.
It's fine. I
Add
promise.
some force to it.
There we go.
Go.
It
Go,
it
go.
catches up.
Oh no! Oh, flip it over! Is this a very convincing demonstration?
Yeah.
Yeah,
So,
you have to convince-
If you increase the mass, you're gonna add more rotational inertia, harder to get it to go. If you distribute that mass farther from the center of rotation, it's gonna be harder to get it to go. But once it's going,
It's hard
go.
to stop.
harder to bring it to a stop. Okay? Now for the classic of all time physics demonstrations. All time classic physics demonstration.
Oh,
I
Juggling.
thought a ramp was the.
Is this your favorite
I feel
demonstration?
like juggling.
No.
Yeah, it's a ramp.
I thought the Newton's Cradle was the all-time.
That is a good one.
Oh,
This is also a good one.
What is your favorite physics demonstration?
What's that?
What is your favorite physics
I don't
demonstration?
know. That's a good question.
Juggling.
It's gotta be.
I'm sure I have a favorite.
Yeah, the day before
Yeah.
Christmas, right?
Horrible.
That was the best day.
I still know how to juggle.
Yeah.
You better.
I can juggle
I
like
don't know how to
juggle.
All right, you guys ready?
Give me any object, Mr. Pat, I can juggle.
So I have two objects here.
How about a chair?
What do you notice about their sizes?
They're the same.
They're very close. Okay? All right. These are very close in terms of the radius. Is that cool? And we'll have Jasmine be the demonstrator here. Hold them in your hand. Do they feel like they weigh the same?
Yeah.
They do, right? What do you notice about this one's metal? This is called a hoop, right? And this one's called a disc.
It's like
They have very specific names.
It's like a bread and a bagel.
Are they the same mass?
They are. So they have the same mass, they have the same radius. This is the disc, this is the hoop. Okay? Luke, will you come up here and be the official catcher?
Oh, I love
It
it.
doesn't
Oh, wait,
matter.
oh.
Yeah, sit down.
Oh, wait,
does
wait,
not matter.
no, come on.
I ain't sitting.
No.
Now, I'm
You
gonna,
wanna both do it?
gentlemen, we got limited time. Let's go.
Mass.
Should I let it roll or just catch it right away? Like,
Which one?
You're gonna get it when it gets to you. So watch closely.
The
Ready?
black one's gonna be slower.
Okay? Do you guys feel that? All right, so we're gonna do this. Now, what I'm gonna do
Hey,
is I'm gonna put these on the ramp.
shout out.
Oh my god.
And I'm gonna let them both go.
Oh,
And I want you to predict what's gonna happen to the spacing between them. But to make it easy, I'm gonna give you multiple choice.
oh,
Oh, wait, hold on.
I like magic answer C.
Secret answer C?
yeah.
A, the spacing increases as they roll down. B,
Lay down.
spacing decreases as they roll down. Or secret answer C,
I like,
Stays the same.
spacing stays the same.
I like C.
Check your neighbor
Wait,
now.
The disc is in the back,
Yeah.
Because
Same mass, same distribution.
so
That was so lonely.
to roll down the ramp, it has to
bigger
spin.
distance.
And I think the
Increases or decreases?
black
Yeah, wait.
has more
Distance.
decrease, so I'm gonna go with B. And so it's gonna be.
You going B?
Let us know what you think down below in the comments.
All right, you guys ready?
Even though it has the same mass.
Claire, did you check your neighbor?
Sad.
What does your neighbor say?
The mass has more radius.
That's
B,
a good beat.
spacing will decrease.
It's not the actual radius of the disc.
What's that?
That's not the actual radius of the disc. That's gonna change it.
She says spacing decreases. All right. Anybody care to disagree? Anyone say spacing increases?
Spacing decrease.
Spacing increases.
Who says spacing stays the same?
Oh, we gotta go with C.
Secret answer C? All right, you guys
Oh,
ready?
I think it's A.
Whoever turns out.
Ready? Set. Wait, what do we think is going to happen?
C.
C.
Stay
A.
C.
the same. Increase, decrease, stay the same.
Decrease.
Increase.
Hey, give me B.
Can you see the spacing?
Wait, yeah, increase.
Set. Go.
Yeah!
It stayed the same. I stayed.
That definitely did not
No, no.
Now,
User error.
because I know the outcome, I mean, we saw what happened. Even if I put them like literally right next to each other at the start.
They'll stay there.
He's definitely not a trained
That is,
Hey.
they are decreasing, I swear to
Yeah.
God.
Now, obviously if I put it the other way,
It probably like hit it.
think it'll catch up?
Yeah.
Oh,
Way too fast.
I did not let them go.
Oh,
Good
One
job.
One job, man. One job.
It's fine.
I can't.
Hold on, one more time. I did not let them go at the same time. That was a problem.
Switch them and they still increasing? So it has nothing to do with.
No, no, no.
No.
No, they're.
I'm just,
He switched from in the deep.
I checked out.
There we go. Oh, jeez. I don't think
You are one.
I'm gonna stand
All right,
over
get
here.
better. If you could, see if you and your neighbor, we saw what happened. See if you and your neighbor can come up with a, like an explanation, like, what is that?
I'm looking at Colin here.
Okay. Go take
Colin, what do you think?
check with your neighbor. See if your neighbor can figure out what is the deal.
RJ, can we have your explanation?
What is the deal?
No, he can stay. He can get an apartment there. He can stay. You go to college.
Wait, what are we
It's
doing?
that mass.
Yeah, why?
Because,
Are they the same weight?
okay, so
Yes.
Has
the
more
radius
radius, so it takes-
weight
The radii are the same.
has a lot.
Yeah, but it's
more
not
I
the-
meant the radius of each like individual like mass.
It's not the radius of the object that matters, it's the radius of mass.
So it goes.
The radius is the distribution of